So try this problem first, and then I'll explain the answer. Okay, so the first thing you want to do is just write down what are your reagents, right? So we have CH3ONa, right? So Na is just plus, and so that doesn't really matter. What really matters is the CH3O minus, because the O minus can act as a nucleophile or a base. So let's see what we can do with that. So a strong nucleophile can act as an SN2 mechanism, and a strong base can act as an E2. So let's go back to our actual molecule. The thing about this molecule is that even though this is a primary, and that's really good for SN2, right? Because SN2 and E2 really like primaries. The only problem with this primary is that it's next to a quaternary, and that's actually an exception to the rule. So when a primary or a secondary is next to a quaternary, it actually won't work because just because the quaternary is so bulky that it stops any bases or nucleophiles from working. It stops the nucleophile from attacking this spot, right? Because if it's so bulky, then the nucleophile can't even get to this primary. For bases, you need a hydrogen to extract, and the thing is, this doesn't have any hydrogens, right? Because carbons only have 4 bonds, and so there's no hydrogen here. So therefore, the strong base can't work either. So the only thing that can happen is an SN1 or E1 mechanism. So if you remember, SN1 and E1, all that happens is the leaving group leaves, right? So the bromine leaves, and then it's a plus charge. So the most common mistake is just to stick the CH3O minus right here. But whenever you have a carbocation form, always look to see if any rearrangements can happen. And in this case, you can, right? Because you can have a methyl shift. So you can have a methyl shift there, the entire methyl group will come over here, and the plus charge will go right here. So now, if you did SN1, well, the CH3O minus would attack the plus charge, right, on the tertiary, and form an ether, right, which is just the O and 2 R groups. And then over here, for the E1, the hydrogen here would be extracted, and once the hydrogen's extracted, the hydrogen would be extracted here, and then once that's extracted, then a double bond will form. And thus, you have a double bond form, and then you have your E1 product. So whenever you have SN1 or E1 products, they're usually 50-50. And so your professor should take either answer. If that's not the case, then just ask them what they would prefer. So I hope that helped, and thanks for watching.